Right. Okay, just a little bit of a revision. When you do differentiation, you have something like this. And then what is the dy dx? Okay, so now what you want to do is the reverse. You're going to go backwards from, you're going to go backwards from here to here. Or rather, from this to this. Okay? Right? So you're going to do from, you see what happened in differentiation? The index less 1 and things like that, right? So what you want to do is a reverse. So in integration, this is the sign that you have. Okay, so this actually is the letter S. And then if you drag upwards and downwards, so it looks like this. Okay? Yeah, so that's how it is.
What is that sign called?
Is that if you have x to the power n, so if you're gonna integrate this again, this sign and the letter dx, this is symbol. It must always be that, because as we mentioned earlier, so that dx is a symbol. You differentiate with respect to x. So now same thing, you're gonna integrate with respect to x. Okay, so x is the only variable right here. Similar to when we did differentiation. Okay? Alright? So, as we said, it is a reverse. It is a reverse of differentiation. So what happened? What does this equal? So you have, so earlier in differentiation, the index less 1, right? So now the index add 1. And then you just divide by that result of the index. Okay, so this is what happened. So the basic thing of integration is just this. Okay, of course, another point that you need to look at is when you do differentiation, when you differentiate a constant, what happened to that constant? It disappears, means it becomes actually a 0. So now when you do a reverse, when you integrate, so it would be the same thing, then you must have a constant that appear. Right? So however, whatever this constant is, you wouldn't know unless you're given the relationship between x and y. Right? So of course, typically when you integrate with respect to x, what do you get? You get a y, yeah? Okay? Like your differentiation, you differentiate a y, you get dy dx. Now you integrate, obviously this is your dy dx. So you integrate the dy dx, then you get a y. Okay, so that's the opposite of it. Okay? Okay, just some example. So if you're going to integrate x squared dx, what do you have? So first you write down the variable, which is x. And then what happened to the index? The index at 1. And then you divide by the result of that, which is 1/3 x cubed. Okay, and this is the only place in math that you can, you see in the middle, no way, there's no c, and suddenly your final answer has a c. This is the only place you can write this. Alright, otherwise in every step of the way you must write everything there. Okay, this is the only one that you have to write c at the very last. You have to. If you don't write C, it's not complete. Okay? If you don't write C, it's not complete. So the C must be there. The constant must be there. Okay? Right? So, some more example. Let's say you have 1 over x squared dx. How do you do this? How do you do this? One of the good way is to write this as an index form. What is the index? -2, yeah? So if you integrate this, you get x -2 plus 1 divided by that, which is -1 over x plus c. Are we right? Okay? Can? Okay, then we have trigo, yeah? Integrate a sine x dx, what do you get? Sine x. So integrate a sine x, you get negative cosine x, again plus c. Huh? So integrate cosine x dx, then you get sine x plus c. Okay? So integrate sine 2x dx, what do you get? So integrate a sine, you get a negative cosine. Remember that, how many x is that? It's exactly the same. Right? So this part, when you differentiate, that 2x must be there. Same thing, you integrate, that 2x must also be there. Okay, if it is x squared or whatever it is, that cosine of whatever that angle, that must be there. It must be exactly the same. So after that, what happened? If you differentiate, you have to differentiate the 2, right? The 2x, right? So now when you integrate, what happened? You're going to divide by that. Okay? Alright? Okay? So if you're not so sure how to put that constant, whether it's a half, is it a half or is it a 2 or whatever it is. So what do? You differentiate your answer. Okay? So if you are not so sure, you differentiate your answer, you should get your question. You differentiate cosine 2x, then you get negative sine 2x, and then a 2, yes? So 2 times negative half is positive 1. Right? So if you're not so sure, you will just differentiate your answer. It should give you a question. Okay? So that's how it works. So probably one of the good way to do is actually you have to do differentiating and integrating at the same time. So you integrate one time and then you differentiate and you see whether, you just check your answer whether that is correct. Okay? Alright? Okay. So you have trigo. So what was the last one that we did? You have exponential, right? So same thing, you can integrate ex dx. What do you get? Since you differentiate e, you get e, right? So you integrate e, also you get e. Okay? So what happens if you have 2x? Again, since you differentiate e, you get e. You integrate also, it will be that 2x. Again, but when you differentiate, you have to differentiate the index of that 2x. So same thing here, you divide by that differentiation. Okay? One that which is like this. So how do you integrate this way? So this is kind of like a chain rule. It's kind of like a chain rule. So you are going to assume that this whole thing is like an x. So you are integrating an x squared. Okay, so to speak, yeah? So how do you integrate an x squared, or what is the result of that x squared? So it will be 2x plus 1, and then the index at 1, and then you divide it by the result of that. Okay? Now what's going to happen here is that when you do your chain rule, after you differentiate your power, you have to differentiate what is inside this bracket, right? So that is when you do differentiating. So same thing here. When you integrate, after you've done that, you must also divide by differentiation of what is inside the bracket. So you differentiate 2x plus 1, you get 2. So this time you are going to divide by 2. Okay, so that 2 is down here. Okay, so it becomes 1 over 6, 2x plus 1, and then cube plus c. Okay? Not so sure whether it's correct? Differentiate your answer. So you differentiate that bracket, you get 3, and then whatever in the bracket and square, right? So 3 divided by 6 is half. And remember, you have to differentiate 2x plus 1 again. So half times 2x plus 1, so it's a 1, so that gives back your question. Okay? Definite integral. So what is the meaning of definite integral? It's like if you differentiate something. Okay, let's say I'll give you an example. X cubed dx. So there will be two numbers here. Let's say 1 and 2. Okay? So things like this. With that number, there are 1 and 2. These are called definite integral. Okay? So what are you expected? What is your expected solution of definite integral? It is a number. Okay? It's a number. Right? So what you need to do here is this. First, because it is still an integration, so you have to integrate it. So you integrate an x cubed. So again, how do you do the integration? The power, add 1, and then divide by the result of that. Huh? Now this you have already integrated. Once you already integrated, because it is a definite integral, you have to change the presentation into a square bracket. And then you are going to move. Okay, that 1 and 2 are called the limits. Remember that lim? Okay, so that lim are this. So this 1 and 2, now you're going to transfer it to the right hand side. Okay? Alright? So what are you doing right now? Now inside that square bracket is a quarter, right? 1 over 4 x to the power 4, okay? So this is 1 over 4 x to the power 4. 1 to 2, okay? So what does this equal? So you're going to substitute x for that value of 1 and 2. So how do you substitute? You substitute when x equals to 2 minus when x equals to 1. Yeah, why is it half? It's not a half. It's a quarter. Okay? Right? So it becomes... Okay? So it's always the top one minus the bottom. Always. Yeah? So that's how it works. It's always like that. Yeah?